This video is about the Bronsted-Lowry theory of acids and bases and the terminology of conjugate acids and conjugate bases. So according to the Bronsted-Lowry definitions, acids are substances that donate protons in a chemical reaction, and bases are things that accept protons in chemical reactions. Now, this is related to the Arrhenius definition, because remember, a proton is an H plus ion. So we're still talking about H plus ions, but now you have to actually see a chemical reaction in order to determine what is behaving like an acid and what is behaving like a base. When an acid and a base react, the acid donates the proton to the base. So remember, we're talking about H plus when we say proton. So here's the equation that we're going to be working with today. And you have HCl reacting with H2O, and the products are the chloride ion and the H3O plus ion. As you can see, in this reaction, the H plus is being transferred from the HCl to the water molecule. And so therefore on the product side, the Cl is what's left over after the H plus is gone, and the H3O plus, the hydronium ion, is what is created when the water accepts that H plus ion. So therefore, because we can see that the HCl donated a proton, we know that that is behaving as an acid, so that's an A. And because the water accepted the proton, that is acting as a Bronsted-Lowry base. Now, this terminology for conjugate acids and bases works like this. The acid here, the HCl, after it has lost the proton, what's left over is called the conjugate base of that acid. So the HCl, after it loses the H plus, becomes Cl minus. So therefore, Cl minus is the conjugate base of HCl. So those two things form a conjugate acid-base pair. All right. Now, likewise, the water here is accepting a proton, and when it accepts that proton, it becomes H3O plus. So this, therefore, is the conjugate acid of H2O. All right, so that is another conjugate acid-base pair. They are interconvertible. The only difference between the acid and the conjugate base is whether there is a proton or not. The acid has the proton and the base doesn't. So for example, here are some examples of conjugate acid-base pairs. So we have HCl, that was the example that we just had. The conjugate base is Cl minus. We could have HF. HF is the conjugate acid of F minus. You can have this with pretty much anything. All right, here's NH4 plus and NH3. That is a conjugate acid-base pair. The acid has one more H than the base does. That's all there is to it. We can keep going here. The bicarbonate ion. That is the conjugate acid of that. That's an overview of Bronsted-Lowry definitions. Thanks for watching.